think we have critical mass, so let's get started. Okay, just a few logistics first. I want to say thanks to Patrick and Mingun. They've helped me with some of the work behind the scenes here, getting everybody's presentations in place. I want to remind anybody online, please mute yourself so that we don't get echoes. This call is being recorded, so in accordance with California law, I have to let you know that. And apologies if you're watching this after it really happened and unhappy because of the time zone it was in. I apologize for the time zone that this is getting done in. But anyways, hopefully the recording will come out well and you get a pretty good benefit from it. Okay, so what are the goals of this meeting? Primarily, it's to review with the community the plans for the EMU release, which is planned for November of this year. I think one of the important parts is to help people with shared interests connect. We're starting to see people want to do some of the same types of projects, so it's good to get visibility so that we don't have duplication and we can hopefully leverage each other's work and get more done. There's a lot more that's going to come into the code base as we have more and more contributing to projects, so we need to be able to at least get a landscape view on the dependencies and start planning for those. And then we also need to understand what our integration load is going to be. So basically, we're getting everyone on the same page, and this will provide the context for our sprint planning. Okay, so I'm not going to go through the agenda because it's just a list of the different presentations and projects that we'll be going through. As you can see, there's a lot here that we're going to get through today. And so I'm going to ask speakers to try and limit their time to 5 or 10 minutes. Some of these, it will be hard to limit to that, I know. And there's going to probably be a lot of interest to ask additional questions. And so for some of those projects, I really encourage the project leads to set up another meeting outside of this one that the community can take part in to do the type of learning on the project that okay. All right, so first up is deployments. So Luca, this is all yours, right?
Yeah. Hi everyone, this is Luca. So we have a few items on the plate. We have these items on the plate. Another one. Can you not use speaker?
What?
Yeah, mute
what?
Yeah, mute speaker.
This one?
Just no volume. No volume. No. Again.
Huh? We're getting an echo through. Oh, it's super. Oh.
There is.
Hello. Okay, go ahead.
Okay.
Taesang, I just muted you.
Yeah. This is Taesang. I just joined.
Okay, you need to be muted. Yep, thanks. Okay, go ahead.
Okay, so as I was saying, we have a few items on the plate. We will keep going on our current deployments, so Internet 2, AMLite, and GTS, so the giant network in Europe. The news is that we are ready finally so ONOS and SDNIP, ONOS Cardinal was finally, we finished the tests and is ready to be deployed in production. We will test it in the test lab of Internet 2, and then we will deploy it. And after that's ready, we will do the same on the other networks. Then parallel to this, 2 new deployments, quite big deployments are coming in. These 2 deployments are not directly managed from us as the other 3, but we are providing quite a big support to them. The first one is Cryonet and Kisti. We already spoke this in other meetings. So it will be the Cryonet S will be the new production research network of Korea. These guys want to implement a bunch of stuff on their network. We are starting with SDN IP as well, and then we will move potentially to cord, packet optical, and many other use cases. ARNet and CSIRO, Australia, these guys are deploying again a new network, fully OpenFlow network with white box switches and ONOS. We just finished to deploy their SDN IP, the first version, and we are moving to the new one. And so they want to be connected as well to the rest of the testbeds that we have in the world. Parallel to this, we need to start all the tests on the maintenance branch that will come out soon of Drake, so ONOS 1.3, that will become the new candidate for deployments. There are a bunch of automated nightly tests that needs to be done, both for functionality and performances. Many people ask for suggestion pages on the wiki that describe not just the deployments and the results, but best practices. So I need to write down a few wiki pages on suggestions and deployment best practices. And last but not the least, in this release, I will be quite busy with meetings around the world that will keep me busy and out. And you have the list there. Mainly, I will go there to disseminate, of course, the results of the deployment. Some of them are talks, some of them are demo and showcases. Sorry, I know I need to go very quickly, but just the last note. Till now, we deployed SDN IP, which is, as you of course know, one of the applications we have. But many people start to think that they would like something more, right? And so it would be nice in the next release if we can start to pick up at least one other application candidate to be deployed on real networks, right? Because we have packet optical, we have cord, but there are still few limitations that don't make these two applications be really deployed by, smaller networks or research networks. So it would be nice to pick one of those and go straight with them and deploy them.
Yep.
Okay, thank you. If you have any question, please ask.
Yeah, also, if questions come to your mind you want to ask while someone's talking, please feel free to enter it in the chat window and we'll address it, certainly by the end of the presentation. Okay, so next one. Why did it go to slide 7? Oh, that's because that's where we are. Okay, that makes sense then. All right, cord.
Hello, can you guys hear me?
Yes, we can.
Great. So for cord, we're going to continue enhancing the VLT application. So there's support for the metering and Q&Q that's currently being worked on by PMC, and we still need to test the group support. We're currently, and we'll be continuing to do this throughout EMU, is build a virtualization for cord using VXLAN and OVSDB. Another larger task is to integrate the fabric into cord, which is proving to be difficult. A work item that's happening at AT&T is the virtual service gateway. Its performance is being tested with preliminary results, and we're still working on that. At some point, we're going to, once we kind of focus and get the hardware that we need for the fabric, we're going to be evaluating the hardware and determining what tasks need to be taken either at the switch OS level, so the lower layer hardware switch OS, figure out what needs to be done there, as well as any changes that need to happen to the fabric itself. we've started a round of discussions about the virtual router, and we need to figure out what it needs to support, as well as, and therefore, based on that, implement the required protocols that it needs to support. And finally, we'll probably start designing the IGMP snipping application to handle multicast traffic. That's that.
Okay. A couple of things that aren't carved out here, but I know we have goals for, right, is to get together a development pod that can be replicated between different sites, right? So that will fall into this time frame. And then hopefully by the end of this release, we'll be most of the way there to a more scaled out version of that pod. Is that true?
Yes, so the idea for the development pod is each component of the development pod will be made available either as for example, for networking as Mininet. XOS will be available through ON.Lab, and we'll try to stitch those pieces together on a per development pod basis. We kind of don't want to spend too much time trying to put a development pod together, and then trying to replicate at each site, because that's going to be very time consuming. So the idea is that the people who are participating in core development can take the parts that they're interested in and develop on that particular environment without necessarily having the full environment in their hands. Does that make sense?
Yep.
So the question, what's your branch strategies? So I heard the individuals were develop their own. When to merge in, back to the ONOS branch, master branch?
I mean, as the different applications that are needed for Cord become ready, they'll be merged into ONOS as we move ahead. But the development pod itself is kind of like a collection of these applications put together. So that could be XOS as well as ONOS, as well as it's basically a collection of XOS and ONOS and other potential hardware elements that you may need. So it's not clear to me how, we can definitely put documentation on the wiki of how to build it, but I don't know that we'll have a VM that will contain everything, and you can just download the VM and have your development environment ready.
Okay. Yep. Okay. Good.
Yep. Okay. Thanks.
All right. Is that it, Ollie?
Yeah, that's all.
Okay. Okay. Next up is the. Yes. So before you start, I just want to say a couple words. So Cord, we started with the kind of the residential use case, but Cord is expanding to other use cases as well, and one of them will be in the mobile realm. And so Min Goon from SK Telecom will go through this, and you've got a lot of slides.
Yeah.
So
yeah.
pick the few that you want, and
Okay.
okay. So do you want to run it?
Okay. As you heard, we're gonna add some mobile use case to existing core project. The first one is service at mobile edge. I wonder if you are familiar with mobile network architecture. If we divide it two, you can say that there is one, it is called edge, and there is another part is called core. Edge is the place where the mobile radio stations are located, and core is the place packet systems are located. So today, every service is done at the mobile core without. So every traffic should go into the core of the mobile network. So, but this causes lots of burden on the network itself. So we are going to move the service function to the edge of the mobile network. By doing that, we can reduce the latency and we can reduce the load on the network itself. I will skip this slide. So this is the POC scenario. If you have a big sports event, there are many spectators watching the game with smartphones. So for this scenario, we can send the traffic from the mobile edge without sending the traffic the centralized core. So using the core architecture, we are going to show this demonstration. We can use XOS for installing service functions at the mobile edge and OpenStack to implementing the virtual infrastructures. And ONOS can be used to control the mobile fabric. And to do this, we need lots of functions like DNS and local device packet core or video cache functions. So we are having conversations with the partners who can provide these solutions. So after we decide the solution provider, we gonna do demonstration at the end of this year, and the target POC is ONS 2016 next year, March next year. And the second one is done by Tom.
Okay, so the second one really is more about RAN virtualization, eNodeB, disaggregation of eNodeBs, as we are doing the same thing with the ROADMs. So, if you don't mind, just keep going, flip slides. Today, we have a lot of proprietary control plane embedded in the eNodeBs, and those are examples of base stations or eNodeBs, etc. And some of the data plane functions are in blue, and some of the control in proprietary. So what we are going to do is show that some of those functions can be virtualized, and we'll go to the next slide. And I think we are going to similarly, can you skip this one, to show that some of the mobile applications of eNodeB can become northbound of BBUs, which in a sense is really sits on top of core, and that's why we call it M-core. So really is more about virtualizing the eNodeBs into the commodity servers as well, with some acceleration capabilities built in. And many of the, and you can go to the next slide. And so this is sort of the model where you'll have core applications in green, and some of the BBU racks will have some of those functions built in. And we have to worry about front hauling, I guess, which is communication of these BBUs to the remote radio heads, which is about 10 to 20 miles away. So delay budgets are tight, like 3-4 milliseconds, time frame, but it depends like how much functionality you put in remote radio head versus eNodeBs or BBUs, and then we should be able to showcase some of those, higher level scheduling function, power control, or load balancing, and other functions that SUN, which stands for self-organizing network, have not been able to met in the industry. Perhaps we can, use SDN to support this. I think that's it. The rest of the slides represents, how we are going to do core, previous slides and showing that, and this one's more of schedule for March 2016. Then we're working with, some of the partners such as, I guess, Cavium, Cavium and Nokia and Lime Microsystems, Altera. So those guys will be coming here, visiting us soon to get this up and running.
Cool. Okay. Questions? Okay. Shrikant.
Okay, Shrikant, he's here.
Yeah.
Yeah, he's online.
Okay. Hi everyone. This is Shrikant from Ericsson. I'm going to give a quick overview of this ACORD project. As many of you are aware, this project or use case was introduced in the last release, for those who are new, the goal of this use case is to build a platform that enables the analytics inside the central office in the card setup, such that vendors can bring their own analytic applications running on top of this platform and run their analytics algorithms and feed back the actuation decision into the orchestration platform like XOS. So this use case focuses on building that platform, and that platform must have some of these, like controlling the level of instrumentation in the underlying devices. And platform should be able to instrument the services, not just the devices. And it should be able to transform this probing information into aggregation. I mean, it should be able to aggregate or correlate this probing information. And last but not least, this platform should be able to provide a mechanism where the traffic can be redirected to a probe virtual machines, which can do a deep packet inspection and extract some metering from the traffic. So these are the high-level goals of this use case. Bill, can you please go to the next slide?
Okay.
Yeah, so just showing whatever I have said so far in the picture. So this is the focus for the card market trial Q1 2016, where we wanted to build this platform, which is the center of this picture, that gets measurements from different elements in the central office, like commodity servers or the services running on top of the servers, ONOS, or even the white box, which are part of the fabric, and the IO nodes like OLT, GPON, or any kind of device, IO devices in the central offices. So collect the metrics from these various elements and provide them to the applications that are running on top of this platform, either through the query interface or the PubSub based notification framework. So we are targeting to bring some open source applications running on top of this platform. And also, if any vendors are interested to bring their analytic applications running, integrate with this framework, that we are happy to help you to work there. Yeah, this is the high-level architecture of the platform. Bill, can you please move to the next slide?
Okay.
Yeah, if we zoom into that XOS analytic framework, which is the center of the previous slide, these are the different components inside that framework. So as you see, the framework will provide you the notification-based publishing of the events from different elements in the network. For some of the legacy elements which don't support this notification-based publishing, they can provide some APIs which can be extracted using these polling agents. So both notification and polling agents will centralize the measurements, which can be exposed to the applications or modules running on top of this platform using the query interface or the PubSubs. So the applications here, we are calling them as event correlators. So they can correlate the events coming from different elements in the network and either run their analytical algorithms, or in future these event correlators could become another first-class citizen of the XOS, where the correlated events can be fed back into the framework so that some other applications can utilize those events. In parallel, we also wanted to develop a framework which is called Dynamic Analytic Platform, where in some cases when the devices are not capable of doing some kind of deep packet inspection or deep packet analysis, this is a framework that can be leveraged by these applications to spin up their own probe virtual missions and configure the network such a way that a selected traffic can be pointed to these VMs where you can do this deep packet analysis and fetch additional information or measurements from the traffic and feed back into the framework. So yeah, can you Please move on to the next slide. So we are planning to do this in a phased approach. As I said, this whole thing is targeted for the market trial Q1 2016. But as an initial step, we wanted to target few basics things such as like leveraging the existing OpenStack Ceilometer framework for this whole platform. As many of you are aware, the OpenStack is a project called Ceilometer that has a lot of overlap with what we plan to do in this use case. So we thought that is the right base platform on which we can build on top of it. In the initial phase, we wanted to go with the query-based interface only. PubSub will come in the later phase, and also integrate with the existing code elements like CPE, OLT, BNG services into the Ceilometer. Also, ONOS also will be integrated. Then bring this Ceilometer into XOS as a scalable multi-tenant service. So that multiple applications can have their own slice of the Ceilometer service and view the meterings that are associated with that particular tenant. And to demonstrate these capabilities, we wanted to write a small dashboard kind of application on top of this platform, and also parallelly evaluate whether this framework can fit it into the bandwidth intensive environments like mobility. This is another task we plan to target in the phase 1. In the phase 2, if you can move to the next slide. Yeah, we wanted to expand this platform so that it can provide the PubSub kind interface to the applications instead of query, so that applications can get a direct notification whenever some metrics or measurements change. Also, we wanted to provide a control of turning on and off of these meters at various device levels. And we wanted to expand to the devices that we are instrumenting to the card fabric or IO nodes like OLT GPON, and build few more analytic applications like auto scaling or customer care or elephant flow redirection on top of this platform to demonstrate the capabilities of this whole framework. Yeah, that's all I have. If you have any queries, either you can shoot it now or you can send a mail.
I have a question. Can you hear me? The question is that is the cord fabric includes collecting something from the Broadcom chip?
Correct. Card fabric, I am referring to the white boxes inside the card fabric.
So that includes collecting something other Broadcom chipsets, right?
Correct.
Okay, thanks.
Shurikan, I have a quick question. This is Taesang from Metri. In your analytics use cases and applications, you mentioned 3 things. I think the fault analysis, especially root cause analysis through this analytics platform is one of the good use cases and application. Do you also consider that?
There was little disturbance in the background. So are you indicating different use case apart from the 3?
Yeah. Yeah, like fault root cause analysis.
Okay. The customer care application that I have listed here, that might include some kind of root cause analysis. Again, we don't have enough details on the applications that we are going to build, but this is one of the things that came up from the AT&T, something similar to the root cause analysis. When some subscriber calls the customer care to find where the customer care will enable different probes and different elements in the central office to find where exactly he's getting this problem from.
I have one more question. During your presentation, you mentioned about DPI in your framework. Could you elaborate a little bit more on how you are using DPI in your framework?
Yeah, for example, for some of the traffic which is going through the card fabric, the card fabric can provide you the L3 level of metrics, but for some reason you want to identify a deeper level of for example, I mean, just an example. So you want to detect some anomaly in the application traffic that is going through this fabric, which obviously we cannot turn on inside the fabric. In such cases, applications can leverage this platform to bring up a VM with their own image that can do this deep packet analysis of the traffic going through the fabric and find some kind of anomaly and notify the applications based on that analysis. So that is where we wanted to provide this platform to the applications where they can provide their image, which can do whatever type of analysis that they want to do on top of this traffic and extract the necessary information and feedback to the applications.
Okay, thanks.
So as it is shown in this picture, the last part, that in the dynamic analytic platform and talking to the probe VMs, the image comes from the application. So the application can decide what kind of deep packet analysis that they wanted to run on the traffic. So this dynamic analytic platform will configure the ONOS to redirect some selected traffic to this probe VMs, so that the deep packet analysis can be run on that selected traffic, and the resulting metrics can be fed back to the Ceilometer framework, or it can be directly given to the applications.
Okay, so we should probably move on. So thank you, John. Okay, where's Patrick? Patrick or Hong Tao, you gonna do this one? Okay.
I will hello everybody, this is Hong Tao from Huawei. In this release, we will continue. We will continue our work on the ONOS framework for the OpenNFA project. And in the direct release, we have implemented the L2 services supporting in the ONOS framework. In this release, we plan to work on to support the L3 service. So the target to achieve in this release include a couple of things. Firstly, we will support the communication between the VM virtual machine within the same tenant. This virtual machine may be located in the different network, actually mapped to the low layer network. So we support the communication between this virtual machine, and in this, so by supporting this feature, so the customer in the tenant, they can communicate with each other to share some file, whatever, any kind of network services they can build on this tenant network. And another feature we will support is to allow the virtual machine to access the internet. And also we will support to migrate the virtual machine within the same internet network, so the customer, they can balance their workload and do something, whatever. So we support this migration. And the code implementation, we will develop a couple of modules to support these features. Firstly, we need to implement the L3 plugin driver in the neutral OpenStack neutral side. So that driver will talk with the ONOS application layer for the L3 resource. We will use the REST service, so RESTful call. So we have to, we need to build the REST service in the ONOS side. And also we need to extend the resource management for the ONOS FW. This resource management actually includes the tenant network resource information. This information is stored in OpenStack Neutron, but we need to sync up with ONOS side. So in the ONOS side, we keep everything about the tenant network resource. This is for the L3 service. This includes the IP table and maybe gateway information, some L3 capability. And also we need to modify the VTM manager. That VTM manager will talk with resource management and get the resource information and install the L3 flow to the OS network. And also we need to modify the OS pipeline driver to install the L3 table. And also include the virtual machine migration. For the migration, we will invalidate we will remove some invalidated table and move it to another virtual machine through the VTN manager. Yeah, this is basically the work we will do in the new release.
What's the example of messages that goes between the VMs? Is more of state information?
Yeah, the message actually we just provide the support in the network infrastructure. There, actually, customer you use this network, you can share some file, you can do some other service in this layer 3 service. You can transport the file to another virtual machine, whatever.
So the one thing I can add here is something like the east-west one. So you build the overlay network. Okay, here is the talk about to build the tenant network, right? Mm-hmm. So you want to do some things between the east and west one, which is the communications between the VMs. So it's something about it.
Does it like separates the networks from privacy and?
Yes, it's a tenant that own the two separate network. So they want to talk to each other. It's like the accounting department. They want to talk to the two separate network. Give the different things. Yeah. Then you want to access something in between. So it's.
And these are not just protocols or signal. I mean, it could be file exchange.
Oh, anything. It's an L3 network.
L3. Yeah. Nice.
Okay. Anything else, Hotel?
No, thank you.
Okay. Service function chains.
It's what is the Saurabh? Are you online? It's Indian. It's their time now. It's in the morning. It's a very early.
Pretty bad time for them.
Yeah, it's yes. Saurabh?
Yeah.
He will join when?
Yeah. I think he already.
No. I saw his name. It's online. Actually. Yes. Saurabh Beer. Yeah.
Yeah.
Probably we mute him.
No, he's not muted.
It's not muted. Okay.
Nope.
Let's mention his name and we'll hear him.
Okay.
Hi, Saurabh. Are you there? Okay, I think that we probably can skip this one. Let me start on my part, and then once he's ready,
which type is it? Is SFC? Is it?
It's a service chaining. Is basically it's a part of the OpenFV project.
Is which model? Which model of SF?
It's all the logic and built in the OpenStacks. It's not built into the controllers. So the service chaining implementation has two models, right? The major logic functionality is built by the OpenStack. Okay. Another one is you can build it together with the policies into the controllers. Mm-hmm. That is someone else is working on. But the way approach over here is try to build some things in the OpenStack. Yeah, it's an OpenStack application. this one where basically it's offload the controllers. Yeah, so the policies, all these things is a
There
problem.
we go. He says, so I'm here. Can you hear
Okay.
me? So I muted him. So let me unmute him.
Oh, you.
All right, so
Let's go back to previous slide.
So you want me to do first? My part is quick, hopefully not many questions.
Yang, Thomas.
Yeah, I know.
You sure about that?
I know. Okay, I can do my part. So the ONOS has already supported the Netcom, right? They can take the device models and program the hardwares, right? Okay, that part is done. So from the service provider point of view, they want to build the service based on the YAM models, right? So the Tom's later on you can add more information.
No, that's fine.
Okay. Now it's take the layer 3 VPN as the examples. Now you need to specify where is your VPN site is, how you connect between this site, which means the established tunnels, right? So that you have the multiple way to set up the tunnel between the VPN site. Okay, all these service layer modelings and resource modeling models eventually were decomposed into the network element models, which need to be installed on each node. Here, the currently in our ONOS pictures we miss is the define the how to convert this network model and resource model. We don't support now. So this project we were just want to try to build a framework, trial framework to use the applications to handle this network modeling. Okay, and we want to use the existing ONOS northbound API and the resource management APIs. All these configuration architectures to handle the configurations, handle the resource model, okay? And consolidate with the NetConf and the current ones to do the device level model handlings. So here is the overall the pictures. And so we just start to think about these ones. Later on, so we need to team up with the Thomas, Alice, Brian's, everyone's. So these ones. So the Tom, if you have more.
No, it's good. No, you're just saying this is an application to ONOS, not.
Yes, it's an application to ONOS.
The first thing is there's like what you just said has like there's very little motivation behind this, right? You said a bunch of stuff, and it's very abstract. It seems like it could permeate the core. It seems like you want to drill directly down into devices at the northbound API layer. And so I think we really need to have a clear purpose, and we need to clearly sandbox the functionality of the application. It's very vague. It seems like you want to just slam Yang models into the core, and you want to still have explicit device level control at the application layer, which may violate some of the architectural tenets of ONOS.
This will not be part of ONOS.
So the Yang models in the device layer for configuration of devices, clearly that's no brainer. We're going to use that.
Yes.
But they're going to be accessed not via Yang model.
No.
But they're going to be accessed through device drivers /
Yes.
behaviors.
Yes. That's what I mean.
So that's the public facade.
Yeah.
So there's a break in there.
Yeah.
Then at least I thought maybe what I heard you say, interpret me if I get things correctly, correct me if I interpreted things wrongly. If the service layer modeling from Yang would be done separately as a separate entity, potentially using the same tools, ecosystem, but on a separate realm. And it would be wired up to using existing northbound APIs through either REST or potentially through the Java APIs.
Yes.
Correct?
Yes. So the current ONOS architectures support the applications, internal applications and external applications, right? So there's the network modeling basically is implemented in the applications, which are like
External ones or
the
internal ones?
both. So it's which is depends on where you install these applications. Like L3 VPNs, you want to install together with your ONOS instance, or you can run in externally. So it doesn't matter. So
my suggestion would be to pick one and focus on that. Just to make sure we don't spread ourselves too thin, and to also address one use case really, really well rather than dilute the effort.
Sure.
So if you think we're going to be using the Yang models from some other platform, are we going to be using the Yang models directly against ONOS, or are they going to be used? Is this because it's in context of Cord, right?
Yeah.
Is this for context of Cord or context of OpenNFV?
It's the ONOS.
ONOS.
It's
Just ONOS.
Just ONOS. It's nothing related to the OpenNFV. It's separate.
So, okay, so in that case, okay, I would pick either an external runtime environment that uses for running, basically for invoking ONOS REST APIs, not found APIs.
Yeah.
That's one possibility.
Yes.
Another possibility is having an internal ONOS application, which provides access via the models to the internal Java APIs.
Yeah.
Pick one. I would suggest not doing both.
We just start thinking about how to implement this one. So the goal is this. We understand the current architectures as the applications, the cores, and the device, the drivers modeling, right? Okay. So in the applications we handle the network modeling is no problem. The problem is how to translate, decompose the network model into the resource model and the network element model. That is how to link.
When you say the resource model and the network element model, are you talking about resource and network element Yang models, or the
resource Yang models? Yes. Okay. So I have the examples in another file.
I would probably. I wouldn't try to solve it here, but I would try to at least narrow the scope. So basically, we have a very narrow scope and very, like Brian said, have a clear motivation and a clear scope for what it is that we're trying to do. Because any attempt to put Yang into the core of ONOS will be resisted, not just because it's Yang, but because it's a specific technology. Just like we would resist OpenFlow getting introduced in there.
Yes.
Exactly the same way.
Yes.
So it needs to be something that's rather separate.
Yeah.
Also, any direct Yang sort of bypass straight through to devices, there's no need for ONOS to be participating in it. So that should not be in ONOS.
No.
I would keep it that way. I would refine the scope and then.
Sure.
As well. That would be my suggestion. Also, sorry, Bob. Also, there will be Yang efforts going around Cord. And I think Tom is tracking the what? And packet optical. I think all of that stuff to minimize overlaps and minimize confusion need to be synchronized around common effort.
Sure.
All of that Yang stuff needs to be tied together into at least needs to be coordinated to make sure that it doesn't cause hodgepodge of disparate approaches and confusion.
Yeah. So based on my understanding, that's for the core, the currently they want to do is still in the device model. It's the GFast or the OLTs, whatever. It's still the device level. Over here, the picture we missed is the service level. So the layer 3 VPNs, you need to define the layer 3 VPN network models, right? Where is your VPN site? How to connect both each site? All this one is missed in our current support. Okay, what we are doing is this to add to fill in, to implement this picture.
I'd ask you to take this offline with the two Toms. And
yeah, we definitely need to align with the Thomas and the TST members. So the everyone's in the communities. It's a big thing.
And you thought this was going to be quick.
yeah, it's still quick.
I detected the stone.
Okay, thank you.
Okay, Suresh, you want to try again?
Hi, this is Satish here. Just now I called Suresh. Looks like he's having some problem in this mic. So he's trying to check what is the problem. Maybe we can continue. Maybe in the end we can check whether he's ready or not.
Switch.
What do you mean? Oh, right.
No, yeah, yes, it's not. Satish is going to talk about this. Okay.
Okay, but is he online? I couldn't see.
Satish, are you going to present this SFC, or you are going to?
They wanted to see if Suresh could get his mic fixed and come back.
No, what I mean to tell is I just called up Suresh.
Okay.
So I just checked with him. Yeah, looks like he's having some problem with his mic. So we couldn't hear him. So he's trying to check what is the problem. Maybe we continue. Maybe in the end, if it gets corrected, maybe Suresh can present it.
Okay.
Because I'm not very much aware of this part. Maybe in the end we can check if this problem is solved. Then we can discuss about this point.
Sure.
Okay.
Hey, this is Mark. This will be really, really quick.
Challenge.
That's a challenge, actually. So topics for even for Packet Optical. The first one is still kind of high level. We haven't really gotten to breaking it down into individual tasks, but the context is that we want to investigate how we can apply this cap grow drain concept in a metro. In terms of what this will mean for ONOS, I guess this will
Hello.
Hello.
Yeah. Bill. Actually, I'm making a ISD call. Can I take 3 minutes of my time when I finish SSC?
It is an expensive call.
Oh. So okay. So
yeah.
Yeah.
Yep. Sure. Okay. Let me jump back to.
This should be quick. Huh?
Yeah.
You're done.
Okay, take it away.
Yeah. So we want to support service function chaining in ONOS. This is a dynamic service function chaining, and this will be primarily driven by the OpenStack Neutron. And in ONOS controller, we want to achieve the creation of service chain and downloading the forwarding behavior. So the first slide explains what exactly is service function chaining. It's a part of the ONOS framework in OpenNFV. And the SFC basically says ordering of various virtualized functions to achieve a particular value-added service for the customer. And it has got three steps to doing that. First is the classifying of flows. At the ingress, identifying which flows need to be forwarded to which function. For example, for a subscriber who is enabled for parental control. So when it arrives at the ingress, so the service function has to control this policy and apply the rule saying that a particular firewall or some value-added service need to be added to that particular flow. So this we want to achieve from the ONOS controller by doing all the centralized logic and then downloading the forwarding behavior. So can I go to the next slide? Yeah. So basically we will have Neutron on the north, and Neutron once Nova creates the compute node and associates a port. So which ONOS learns using the ML2 plugin, by the way. Then Neutron starts to orchestrate using a couple of REST NBIs, which the SFC manager service, which will be a new service which we will define in the November release. So the SFC manager basically processes the northbound request from Neutron and generates the forwarding behavior using various rules, and using OVSDB. Finally, for OVSDB and the OpenFlow, finally downloads the classification rules at the ingress and the SFP behavior on all the ports which are part of the service chain. Can you please go to the next slide? Yeah, so I've defined a couple of Jira stories, and all this are not yet created. Once this proposal is okay, so I'll create it tomorrow. Please go ahead. Okay, please go to the next slide. Yeah. So basically, the test plan will be to finish the unit test cases within our local environment, and then use Neutron. October 15th, there is one release for SFC networking. We'll use that for basically the orchestration purpose, and OVS with a patch set is available. So we will use OVS patch set for integration purpose on the southbound. And the next slide talks about the demo plan. For demo plan also, we want to use the OpenStack release, which is available after October 15th, and the OVS patch which is available. And we want to create one application that we want to take and clearly demonstrate how exactly a service function chain can be built, and how ONOS fits into the overall service chaining feature, from all the way from northbound orchestration layer to the OVS switch. So that will be the plan for SFC for November release. Any questions?
Yeah. So how much of this is an application, which I would recommend, and how much of this is changes to ONOS, which I wouldn't recommend?
Did you hear Bob's question?
Hello. No, I could not hear it properly.
Oh yeah. So I'm wondering. It seems to me that, like most things that have been presented today, this should probably be an application and not have many changes to ONOS. But could you say which parts of this are an application that runs on ONOS, and which parts are changes to ONOS itself?
Okay. So what we're trying to achieve is the L4 to L7 service plane topology on top of the transport plane. So basically, the first part of creation of compute node, the VM, the port association is directly done by the Neutron by passing the ONOS. So once the port information, the service function instances are learned by ONOS. So further, the creation of port pair group, and classification function, the service function download function that's using the NSH header. So this part, Neutron depends upon ONOS to actually generate what kind of forwarding behavior for that particular pair, and use an appropriate southbound API and configure the devices. So basically, the initial part is done by the Neutron. The forwarding behavior generation and configuration of the forwarding behavior onto the OVS nodes across all the ports of the service chain. So this will be done by the ONOS.
I was assuming it was going to be all one application.
It should be 100% application. And
I mean,
but it does seem like
an internal application, but running inside the ONOS framework. But it's really an add-on. It's a selective add-on. It must be because this is not something that's going to be required universally.
But it does seem there are some additional ONOS changes as well. Like, for example, OpenFlow does. If OpenFlow spoke VXLAN, then you could just use OpenFlow. But clearly, you need another mechanism to set up VXLAN.
Yeah, so there's drivers.
Yeah,
so that you would, for any device provisioning or device orchestration, you would use the device driver framework. And yes, that might require modeling new functionality, new abstractions through which you would accomplish that, but within that mechanism.
Yeah.
And then just like we took the approach with the VTN application to model virtual networks, the service chaining ought to be, if it wants to be embedded inside ONOS, it needs to be embedded there as an application, so that it remains selectable, because the core itself isn't selectable at runtime. So applications could be thought of essentially as just selectable features at runtime, but they're as much as part of ONOS as they are as anything else. It's the only difference that makes between them and the core is that they are selectable.
Yes, over here I agree with what Thomas said. But I just want to raise the one concerns and one questions. So now if push all this universal the accessible or usable the features to the applications, we could how can we use the course persistent stores all these HA features in the application?
No. So it's an embedded application, meaning it's an internal ONOS application that gets distributed across the cluster. And just like we have examples of applications today that use the distributed primitives, high availability constructs for leader election and failover and things like that. There's no difference with access to those capabilities.
And core
if you're an application, it's just the same.
Okay.
Everyone uses the same set of primitives for achieving HA scalability and everything. So as long as you're running on the on the ONOS platform.
Okay.
Applications really all should be thought of as basically like super features in a sense that they're distributed. The features that are activated, deactivate across the entire cluster. They're part of ONOS code base. They go through the same review, and they just remain selected.
Okay.
So I was making that assumption myself, so I'm glad Bob asked the question because I guess I shouldn't have.
Yeah. Thanks, Bob. Good question. This is one I think that would be a good example of having a follow-up meeting to kind of understand more of what's going on in it.
Yeah.
Okay. We can probably schedule meetings with you. Yeah.
Okay. All right. So back to our optical scheduled program.
So cap grow drain in the metro. The point I was trying to make was the way I see this play out is from ONOS perspective, this will lead to a couple of applications that support specific services in the metro. Whether that is video distribution to get the multicast tree set up across the metro in a converged packet optical way, or connecting, setting up VPNs, layer 2, layer 3 VPNs across the metro. I think those are the kinds of applications we're looking at right now. Another much more concrete task here is that fairly recently we had a new resource reservation API. Packet Optical uses a lot of reservations on devices, on links, and all of those things. Show stepped up and cleaned all of this up and created a much nicer API. But we need to port the application and the various compilers to use that API. Then a third point, just very briefly, we won't get into a messy discussion. All of this is suggestion is to come up with Yang models, that a service model for bandwidth on demand in a packet optical scenario, right? How this will eventually play out, I can't say right now, but there is a clear demand to do something like this. Then the next one is this is ongoing work. It actually started a couple of weeks ago, adding support for OTN multiplexing in ONOS, something that is in high demand by various vendors. Some people want OTN to go away, but others really don't want to do that. So we're doing that with the help, mainly driven by ECI Telecom. And then the final one is again kind of high level. It hooks into that metro aspect where we're still in this is just talks right now, but coming up with a model for disaggregated ROADMs. And the way I see this evolving is that if we want to go down this road, it will require significant changes to models, certain data models we've made for packet optical and ONOS. From a very high level, what we're doing right now is we're looking at devices, we're controlling whole devices. If we go to this disaggregated ROADM model, we're really controlling individual components. Right? They come together in a device, but we're talking to individual components. And that changes things quite a lot. Not just in terms of control, but also a lot of issues with scalability, HA, and all of that.
We need to model
almost model the internal device
Yeah,
topology or something.
yeah, exactly. You need to know I'm talking to a transponder. You're controlling an individual pluggable optics module. You're controlling the ROADM. All of this separately, right? Not just with a single command and you're done, right?
On the middle bullet with the E2 E line, does it help you look at the Metro Ethernet forum slides and see if you can, I guess?
Yeah. So yes, it does. But this is much more concrete. This is saying, okay, let's do it in Yang and see what happens. But I kind of defer questions about this to Huawei for now, because I don't really understand it quite. Yeah. Any other questions? No.
All right, good, next, Mark.
Hi, this is Ping Ping. The first part is Luca conclude several test cases for the Internet 2 deployment. So I will implement those test cases and running through the Jenkins daily. The second part is to continue to solve the issues discovered for the 600,000 routes. This is still a challenge for the EMU release. The third part is there will be two talks and training in China. One is the Huawei Developer Conference, another one is the CCF China Communication Federation talk. The last part is to implement some trivial functions left on the Jira backlog. I just list here for some example.
Okay.
Okay, that's all. Thank you.
Okay, short and sweet.
This is real short.
Well, she didn't have Yang on her slide.
Thank you.
Okay, Rusty, you're out there.
Yes, I am.
All right.
So for the next sprint here, a lot of the effort's going to be focused on, testing the PIM stuff and, getting it ready for production, toward the end of this year, hopefully. Some pieces of code are surely missing that I don't realize are missing yet, so those will have to be added. Some CLI and REST commands. Continue to do a little, some more work on the IGMP snooping and maybe a little bit of proxy stuff, which probably means a good idea that maybe we get together and talk, Ollie, at some point in the near future. And also, I'll be working diligently to get changes that I have in my local repository moved on into the real one. And that's the bulk of it.
Okay. Good. All right. Any questions? No? Okay, thanks, Rusty.
Sure, no problem.
Okay. Taesung, is this you?
Yeah, yeah, I'm here. Okay, okay, the slide I sent you has been trimmed down into 3 lines. Okay, so the AFS work has been implemented, has been pretty much done, and this the system testing is in progress now. And also we add the option to make this feature to be turned on and off based on the configuration. So basically that's a quick update on AFS. And I think you missed one point that I added here for our future plan for EMU release. In AFS, we have pretty much done with basic implementation, and we also have a additional feature, the advanced sampling feature, and we are currently working on that and targeted toward email release. So that's another future work. And do you have my second slide? Or you didn't add my second? Maybe you didn't add my second slide. For another future work, actually I sent 2 slides to Patrick, and maybe it hasn't been somehow incorporated into the slide maybe. But anyway, I can.
Sorry about this. I think I sent you the email and the.
Oh, you're adding to the. Okay. Yeah. I haven't done that. I thought it was.
Okay, sorry. So
No, that's okay. But the second future work that we are planning to do is about selective DPI feature. Yeah, like what we did in AFS work, we are going to we would like to add a selective DPI feature in the provider of ONOS, and bring some application, the ONOS internal application through this based on this selective DPI provider. And the reason I asked the question to a court team is that there may be some possible lapse between our work and DPI functionality within a court framework, but it seems that it's slightly different. Our work tried to address in the ONOS itself, including the provider core part, but the DPI in the court seems to be pure application on top of ONOS. Actually, it's even ONOS is just bypassing the particular flow that needs to be DPI needs capability of DPI to their collection framework, and then do the DPI there. So the focus and the scope is slightly different. Yeah, that's brief update from our side. Thank you.
I'll come back to you offline on the DPI part.
Okay, any other questions? Okay, thanks, Tae-sung.
Okay, thank you.
Yep, bye. All right. Thomas, are you gonna cover this one?
Yeah, so the fault and alarm management subsystem, that's a functionality that's going to be provided by an external contributor, ETI from UK. And we had a brief meeting with them where we already discussed sort of the overall design and overall objective. And the idea here is to build a system through which we would be able to collect alarms, basically faults in the environment, and be able to track them in a distributed manner and provide ability for an administrator or a programmable entity to clear these alarms. And so the BTI will drive design and implementation of the feature. There's a link provided to the initial sort of overall proposal, as well as some background about the company. And we will be working with them in the coming weeks to start the review process, and the contributions can start rolling in.
Thomas, I have a question. So can you give an example of what you have in mind here? I understand like faults and alarms in the context of hardware.
Yeah.
But in the software hardware, what do you mean by?
Yeah, so faults and alarms happen usually in the elements, right? They could also be synthesized through some observations and combination of other events, right? And they can be injected in the system to notify the administrator or potentially some monitoring entity about anomalies in the environment. And so this will be delivered as an application, so it will remain selectable at runtime because not everybody will need this. It will use the provider mechanism, so there will be one subsystem for tracking this and store for distributing state and distributing the acknowledgements. And then there will be one or more providers that can be hooked to this to be able to collect the data either through SNMP, netconf, or other means. The first implementation, and I forgot to put this on here, will comprise of a ZSNMP V2C provider, and that will be just the first example of the provider for the alarms or collector. We think of it that way. Is that reasonable?
Yeah, but is there one like objective? Someone has a request, he wants to run some kind of network where he has.
Yes, BTI. BTI has, yeah, they have a specific set of requirements with support for IPv6 and stuff like that. And essentially, this is our first foray into what could be construed as a network management functionality.
Okay.
For example, if there is one ONOS instance is down or there is no path to computer internet, will I receive the alarm?
So it's certainly possible that we could use alarms for that purpose. Right now, this is mostly envisioned to provide alarms about the elements in the environment, not necessarily the elements in the software. But so it could be. I mean, it could be construed that path, loss of path, could result in an alarm. But whether or not something will generate an alarm, that remains a design decision we'll have to make later. Right now, we're just working on a system to be able to collect faults from the environment, things that the switches and other network elements collect to produce. All right. So hopefully that's enough. Any other questions? If not, that's all I have here.
Okay. Thank you.
Actually, I have one quick question. This is Kasang again.
Hi.
In the code framework, I asked whether they are dealing with fault analysis. Should this fault and alarm management has any relationship with that as well, or are you considering talking with that team?
The first goal for this is to just collect, track, and allow management through sort of acknowledgements. Whether or not there is the plan right now is, at least not the immediate plan, is to write any analysis on top of this. That could be done as a separate piece of functionality to be able to look for patterns and synthesize other alarms or potentially synthesize remedies for the conditions. So that's currently not in plan for this, but it's certainly something that would be very possible to do. Did that answer your question?
Okay, thank you. So this is basically on collecting and detection of alarms, raw alarms, without having deep analysis.
Correct.
Yeah. Okay.
Correct.
Okay. Thank you.
Consolidation or anything like that.
Okay. Let's see what's next. Okay, test infrastructure.
Okay, so we decided to kind of split this up into two areas. One is, I guess, code coverage with our tests, and the next one is kind of infrastructure for our testing environment. So as far as increasing our test coverage, the first thing we want to do is write functional tests for the different OpenFlow selectors and treatments. And so actually look at the flows. If we tell it, we want to match this, that the flows actually do match that. The next one is we want to do some work in getting the LinkOE test back into production. It kind of fell behind and they're not working anymore, so we need to get that in. The next is we want to create a platform test that will focus on kind of functionality of like starting ONOS, configuring different things, adding, or the whole application lifecycle, whether it's third-party apps or built-in applications, and then ad hoc clustering will all be part of that test suite. And that will be using both VMs and Docker or clusters or containers. The next is we want to expand our REST coverage. So that'll include moving existing tests that are using the CLI to using REST if it's available, but also adding a REST test for the flow subsystem and network config subsystem. If we have time, that's a lower priority, but I'd like to do that. And then Criterion Networks is still working on the IPv6 tests, so hopefully we can get that done and in our production testing in this release. There's some CHO and HA test enhancements we'd like to do, and if we have time, we'd like to do some virtualization tests as well. And then as far as kind of the test infrastructure enhancements, we'd like to add a real hardware switch into our nightly tests. Ping is going to be working on getting the SNIP deployment test in our nightly production run. There's some traffic tools we want to look at getting integrated, especially for IPv6 testing. And then also just supporting community contributions, especially the OVSDB tests that are being worked on right now. Any questions? Yeah.
So a comment was just that, MoonNet's already a container orchestration system, so most of the time you probably don't need Docker or LXC. And if you think you do, we can talk.
Well, the main purpose here is because we published the Docker.
I see. I think pulling the plug on Docker is a good idea, but I realize if you publish a Docker image, then you need to test it, so that's what you need to do. But for our own use, there's no reason we should ever use. There's no reason we should ever use Docker, probably, or LXC, probably.
The platform test is meant to be targeting whatever we suggest what the developer can do, and we can actually, find out there's a regression problem that's occurring because of code change.
Yeah, I understand.
Okay, thanks, John. All right, Simon.
Okay, hi, Simon here. So in EMU, we're basically going to be focusing on getting the wiki and tutorials up to date, publishing some sample applications to demonstrate how to write code that integrates into the UI. We currently have one archetype for the UI as an overlay, and I actually want to break it into, or rather have three, just as a very quick start, getting your application up and running in under 2 minutes to create a custom view, to create a tabular view, or to create a topology overlay. For the topology overlay, we're going to add more functionality this time. Badge nodes is this concept. If you look at your phone and your mail app, you have a number 3 in a red circle. It tells you that you've got 3 messages that you haven't read. We want to allow application developers to be able to badge nodes on the topology view with whatever semantics they wish to. So that's what a badge node means there. With the overlay button state, that is essentially an overlay can inject their own buttons into the toolbar on the topology view, and we want to allow them control to say when buttons are enabled, disabled, highlighted, or so on. As a slight tangent, we discovered we need the ability to put up a dialogue at certain times to elicit information from the user. And so we're going to create a generic dialogue widget that can be used. And then this will actually be used on the application view. to allow, or rather to implement confirmation of you want to start, stop, or delete an application. We're going to get around to visualizing routers with multiple interfaces as a single node. Now that we have that data available on the server side, we should be able to do that. A little minor one is to add a glyph of a microwave dish. There's been a request that's come in recently. And then also on the topology view, you can see which cluster node the UI is connected to. But if you're looking at any other view, currently you can't see which instance you're connected to. We want to promote that to the masthead so you can tell which node that you're connected to, even if you're looking at other views. Moreover, we want to make that a drop-down selectable so that you can manually redirect the GUI to connect to a different node in the cluster. That's been a request from testing. That's it. Any questions? Yep.
Does the GUI currently automatically fail over when the node is talking to you?
In theory, it does, and it did at one time. We haven't tested that in the
tried it
last week or
recently.
two.
I tried it recently and it worked.
And it did work?
Yeah, the WebSocket connection.
Yeah.
Yeah, it fell over.
Great.
Yeah, we don't have, luckily we don't have security in our WebSocket connection.
It still works.
Okay, thanks, Simon. So, Mr. David Bainbridge has a question. He wants to know why ON.Lab should not use Docker. Now, I don't know if your comments answered that or not.
I think we shouldn't get into that. I think that's just a small.
Oh, well, I can explain in detail, but it's probably off topic.
Yeah. Okay. Yeah, that's what I would agree.
Because the short answer is it wastes everybody's time and resources.
Okay, yeah, I think
there you have it.
Speaking of that, we've only not discussed this thing for.
So basically, you're a fan then, huh?
Well, I have a full Docker. I think it's a fine system.
You guys go have a beer and you can explain the full rationale.
Like the US Open going here.
It's the wrong tool for many jobs.
Sure.
Okay.
All right, virtualization.
I didn't hear that last comment, please.
It's not a bad tool. It's just the wrong tool for a lot of jobs that it's being used for.
Fair enough.
All right. So with the virtualization, today we are pursuing a two-prong approach, and we will continue to do that. The two prongs being here, one is to model virtual networks in a classical style, classical meaning OpenStack style, where they're just collection of ports with implied L2 connectivity, and they can be routed through an L3 plugin. So that's one, and today it's delivered as a VPN application by Huawei for the OpenNFE. There's also, I think, another effort going on by SK Telecom to do their similar approach in their own context. This other approach, that's part of the second prong, is taking more OVX-like style approach where we model the virtual network as a topology rather than just a collection of ports without a topology. And also this topology has no implied connectivity, and instead the connectivity has to be programmed through some means. With OVX this was done through raw open flow protocol, but clearly we can't do that here because we want to be protocol agnostic. So instead we're offering a higher level programming abstraction, and that's either intent or potentially flow objective abstractions. Definitely it's going to be programmable through intents, whether or not it's going to be programmable through the low-level flow objectives yet remains to be decided. So the idea here is to continue the work that was started with Drake on incubating a model, the way the networks are assembled together and are maintained and distributed. And we are going to back the virtual devices and virtual links using intent subsystems. So the idea is to provide a demonstration prototype. It may not be fast, it may not be covering all of the scenarios, but the whole idea here is to continue pressing on this functionality because it's important. But because it's not directly related to CORD, we didn't want to put it on top of our priority list because CORD is our priority number one at this point in time. And Since this is not required, it's taking a second seat for the time being. So roughly speaking, that is it. If there's any questions on this.
Thomas?
Yes.
Could you explain the second bullet, prototype virtual device and virtual link backing mechanisms using intents? What does that mean?
Well, that means, so let's assume that you decide to create a virtual network which comprises of a single big switch device, and that which has 4 ports on it, and those 4 ports are spread across different parts of the network, are backed by 4 different ports of 4 different devices. Somehow we have to provide connectivity between those ports.
Oh, I see. Okay, so you wanna plumb the big switch internal using intent.
Exactly. Similarly, if you decide to create 2 devices connected via virtual link, and the virtual link spans, that's the idea.
It's actually I mean, if you look at it, it's actually the same implementation for both. I mean, the same notion for both. They're both the same thing.
What was it? You tapered off a little bit in the end, so I couldn't hear. It's the same notion as what? As if
actually, that's a side note. But if you actually look at it, the internals of a virtual device and a virtual link are actually the same.
Yeah. No, that's why I put them on the same bullet. I think that would be same, just projected out differently. Yeah.
Sounds good.
Okay.
Thomas?
Yes.
Question. So now is the question is about the cord. So in the cord you are planning to use the ONOS to control the fabric. Okay, spine leaves, fabric, the networks, right?
Yes.
And also use that one to provision the virtual network for the tenants, right? It's a tenant to the network. So now it's a resource manager's point of view. Now we have the device managers. It's only have one device managers. Okay, what's your strategies and plans to use the logically it's a single ONOS controllers to control and manage both network?
Well, so for cord.
For the cord,
for the first trials. This will not be used for that. So for cord, the goal is to accomplish the virtualization and isolation by virtualizing the edge through overlay. And the fabric, whether it's classical fabric or whether it's fabric handled by segment routing or something else, it's entirely different. It's independent. It's an independent part of the network. So there's basically the fabric is not going to be doing any virtualization.
But where to store the topology, the fabric. So for the fabric part, you need to store the topologies, right? For your tenant network, basically you build on the overlays.
So for this?
Yeah.
Okay.
I mean the overall strategy for the ONOS. Now you want to use the ONOS controllers to control the both, right? In the core architectures. Current architecture.
I guess I'm struggling to grasp the context in order to answer your question correctly. So, just to be perfectly clear, this will not be used for cord.
Oh, it's not used. Okay.
It's not going to be used for cord in the first trial runs. So, I don't have an answer, nor does it need to be at least asked, at least in the context of this planning. But we can probably have a discussion offline if you want about long term. Clearly, the shortcoming of the approach the benefits of the approach that we are taking for cord is that it's tried and true, but it also leaves behind, the downside is that it leaves behind the ability to be able to optimize and manage the whole network, including the fabric, and be able to actually use the fabric itself for performing certain network functions that might be better suited to it.
Yeah.
But we're not doing that.
Well, okay.
Thomas, quick related question. So the only consumer right now for virtualization is cord.
Not for this.
No, not for virtualization in general.
In general, well, it's actually, cord is the predominant case, but I think there are other use cases which just deal with plain OpenStack integration or stuff like that. They're going to be doing like OpenFE, right?
Yeah.
What did you mean by? I guess I'm still unclear on what you meant by there is no. I mean, I think Ali asked the same question, but I didn't quite understand the answer, which is what is meant by there is no implied connectivity.
So with OpenStack, expect when you create a network that there's implied L2 connectivity from this port to that port. And that's by virtue of the funding and stuff.
Okay.
In this case, the virtual network will, also the OpenStack one is just a thing of ports. There's no topology in there. So this is almost like a converse of it. If this thing has topology but no connectivity, and you can program your own connectivity through high-level abstractions.
I understand. So
More like
really, this is no different than a, from the application perspective. I mean, this is application level virtualization. From the application perspective, it is no different than talking to a physical topology. You talk through the topology model. The only difference is that it's abstracted and/or virtualized.
Yes, exactly.
Yeah. Okay, got it. And by connectivity, you mean you're not providing traditional IP Ethernet as a service in the virtualization system, which of course is the right thing to do, or which is of course the right way to design it, where you don't mandate legacy IP Ethernet as part of the virtualization system, and instead separate it out as a service that runs on top of it.
Yep,
yeah.
exactly. Yeah. All right, that's it.
Yep. Thank you.
I guess there was another connectivity thing, which is gateways. Presumably those are objects. Gateways to connect virtual networks together, or to connect them to, say, your LAN by the internet.
That's something we'll have to deal with. It and probably will be part of incubating the model.
Okay. Let's see. Do we have someone online for
Changhu's 36,000 feet over the Pacific, but I told him I could cover this.
Okay.
So this is Brian. For security mode ONOS, for those of you that don't know, the implementation was merged into the core in the past week, and so for someone who wants to turn it on, they'll get the security mode ONOS features there. But what we'll be focused on for EMU is testing and debugging. So it's an initial implementation, still beta. There's unit tests that need to be written, and also some performance tests that we should have. So around the performance tests, we'd also want to define some of the metrics and make sure that we're meeting some of our non-security mode ONOS metrics. Around performance, we found out that there were significant overhead introduced by the permission checks. And so there's two things that'll be done this fall. One is when there are trusted core components that are calling other core APIs, we'll disable the permission checking. We'd have a top level call that would have several nested calls, and we do several layers of permission checks, which isn't necessary. And the other thing that we'll do is actually walking the stack and verifying these things using the Java Security Manager is quite expensive. So we can do caching of stack traces so that common code paths don't pay a high penalty for every API call. And the other thing is, as new northbounds and APIs come up, we'll be adding in security and permission models for the new APIs. And the last thing is around documentation right now, and documentation and automation, I guess. Right now, it's kind of cumbersome to enable security mode ONOS. It takes a number of steps. So we're working on scripts that could be used to automatically enable the feature, and then also having documentation and examples around how permissions are defined for individual applications. So usability and performance and hardening is the theme.
So for this trust core component, how do you define the trust core component? The component is OSGI is reloadable.
So trusted core is the ONOS core feature.
I mean, someone could reinstall a new core, new stuff to replace you, and if you bypass that part, so basically it's a security holes, right? So how do you identify the core as the ONOS community released, formal release, or someone did a modification?
So you have to look at what the attacker model that you're trying to get is, right? And if somebody wants to gain access to like the physical hardware, like that's not what security mode ONOS is about. Security mode ONOS is about application software that gets introduced by an administrator adhering to certain permissions. And so the administrator can bypass all the security checks they want. They can install features directly that would bypass security checks. That's not in scope for this project. The scope for the project is you have a trusted distribution that the administrator deploys. That's the trusted core. And then any application that they want to add on top of it would have specific permissions to access certain APIs. And that would be enforcing from the application usage pattern what they can and can't do.
Okay.
So
is your answer then that the application, the administrator is responsible for making sure that the application doesn't replace any core components?
No, that is covered. The administrator is responsible for the core, the distribution that they choose to pick, that they choose to install as their core, like their core feature, needs to be trusted. Once they deploy and start ONOS with security mode enabled, then any application, and most things like OpenFlow, netconf, the driver subsystem, most things are delivered as applications. So all of those applications now, they can't replace core components unless they have a specific permission to do so. So which features that and which services they expose is done as a permission check when the bundle is loaded. But there has to be some trusted code base, and that right now is the ONOS core feature.
So if I understand it correctly, your answer is that when the application is loaded, the bundle manager enforces that an application will not replace any of the trusted core components.
Unless it has explicit permission to do so.
Which is presumably
which would have to be granted like via a permission file and then approved by an administrator.
Got it.
Okay.
Yeah. So applications do have permission to expose services that are otherwise exposed by trusted core, but there is an explicit permission line that needs to be approved before it can be done.
Okay.
Which basically it comes down to which components and which jars it can import and export is controlled by the security mode ONOS.
Okay.
Okay. Thanks, Brian.
Mm-hmm. It's a very good feature. Yeah, it is.
And back to Brian.
Yeah, so there's two main themes here. One is the continued development of the resource service. Did you want to talk about this show, or do you want me to explain?
In direct time frame, I created a new resource API to unify the existing type-specific resource services. In AMU time frame, I will migrate from the existing one to the new resource APIs, and the new resource API will be used in the intent framework mechanism.
Yeah, there's also some other applications that want direct access to resource management, and they would also be using the new generic resource mechanism. So continued development on that. The other thing that we've started incubation on is an intent domain subsystem. And the idea with the intent domain subsystem for EMU will be to continue sort of fleshing out the service interfaces and the primitives that are needed. So exactly what an intent domain is, how they're plumbed together, and then what an API for an application developer looks like. This also will require us to continue to formalize intent primitives. So this is decoupling specific intent types from specific compiler behavior. And hopefully this will also enable, and we can demonstrate by EMU, that we can do cross-intent optimization and also have isolation between intents through the core.
Can I ask a question?
Sure.
Is the intent framework going to be ported to the flow objectives?
The existing intent framework or the intent domain subsystem?
So let me understand. I thought the intent domain subsystem was going to make use of the intent framework.
No, it's the intent domain is the basis for future refactoring of the intent subsystem.
Yep.
And the reason we haven't ported intent to use the flow objectives yet is we're waiting until we're doing that out of refactoring. And currently there's no pressing need for this because a lot of applications today actually use the raw flow objectives already.
Yeah, so.
Yeah. Well, the reason why they're using the raw flow objectives is because the intent framework doesn't scale.
And that's part of the and it doesn't. Yeah, so there's some number of limitations to the framework, and the intent domain is intended to lay groundwork for overcoming a number of those limitations.
Yeah, I mean, I don't know about that. I mean,
well, so maybe the item here, and this is not on this list, but it was sort of implied, is we need to bring together some of the stakeholders, both people that are using the flow objective and other lower level APIs directly because the intent framework doesn't fulfill their needs, and also people that are trying to run multiple applications simultaneously, specifically applications that control routing or forwarding behavior. And so that those two things, overcoming some of the deficiencies and inefficiencies around the intent framework and bringing together multiple applications on the same network were two of the things we are trying to overcome with the intent domain subsystem. So perhaps we can put together a meeting early next week to try to, or in 2 weeks to address this.
Okay, I mean, I don't know that the solution to the intent framework is introducing yet another intent framework. I mean, at some point something's got to give, right?
So I think we need to have a discussion with you to explain the motivation for it. It's probably not the forum for it. I completely register your sort of reservation, and I would completely understand it, but I think once you understand the motivation and what it is that we're actually trying to do, I think that reservation will vaporize. But I'll let you make that assertion yourself.
And let me just rephrase this maybe one more time. The idea of intent domains is to try to allow different implementations or groups of compiler implementations to be plugged in and managed like either across different networks or within the same network. So the intent API is largely going to stay the same. We may change some of the API objects where we may realize that some of them are no longer needed. But this is largely to replace an implementation of a service rather than create a whole new thing from scratch.
Yeah, I mean, I don't know. I just, yeah.
Sure. I mean, we can talk about it later, or I don't know what you want to do.
I know that's fine. That's fine. We can talk later. It's just that, like, yeah. I mean,
yeah.
If we already have enough trouble deploying ONOS on one network, now you're building a new framework to deploy ONOS on multiple networks. So
No.
That's not.
Well, yeah.
This is, for example, operating on optical segment. Right now, how we deal with the heterogeneous networks, for example, between packet optical, is we do that in reactive fashion, which is definitely suboptimal, and that's putting it mildly. And so rather than doing that, we basically are acknowledging that the same intent may have different underlying implementations on different parts of the network. And so this sort of decouples the behavior from the intent. The intent now becomes just a prescription and just a specification of the intent, which is what's in the name. And it allows the different regions of the network to accomplish it differently according to their nature or according to their policies. And we've already seen examples of that, but because of the limitation that we have today by not recognizing that there's different regions of the networks doing things differently, we are forced to having different types of intents. And making it visible and apparent to the outside rather than hiding it behind an abstraction. So I think what we probably could have is a TSD meeting around this, or just a one-off meeting, and then discuss this in more detail. This is probably not the forum for it.
Sure.
I don't mean to dismiss your reservation. I think it's a valid one.
I understand. I mean, but yeah, I mean, that's fine. Sure.
Done. Hi, this is Madan. I'll give an update on the work that we have planned for the distributed core for the MU release. So an area where we'll be focusing on is to support incremental scaling of an existing ONOS cluster. So what we have today, it's possible to run an arbitrarily large ONOS cluster, but the sort of the restriction is that you have to start there. We ensure that we distribute the workload fairly evenly across the cluster, but adding and removing nodes from an existing cluster is something that we don't support. We don't support fully. I mean, you can add a node, but it won't start participating in all the activities that the other nodes are doing. For example, you can install applications on it, or you can like basically access topology and all that from it. But the data that is residing on the other nodes will not be replicated to the new node that you add. So in essence, what you have is a cluster where some nodes are doing more and some nodes are doing less. We want to fix that, and this is an initiative that will let us, incrementally grow a ONOS cluster as your usage ramps up. Another area where we want to focus some attention on is develop some primitives for distributed execution. So this is staying true to our goal of creating simple primitives for doing activities in a distributed setting. Right now we have various such primitives for state management and also coordination, which is achieved through the leadership surveys. But we don't have a simple primitive for doing distributed execution. A loose analogy here is think of the Java executive service, but in a distributed setting. A very common use case that we have right now is we want to have one particular ONOS instance perform a certain activity, and we only want one of those instances to do that work. You can view this as analogous to a single thread executor in a JVM. You have a single line of execution, and all the work gets basically queued on that thread's queue. We want to support a primitive like that for distributed execution. So when someone wants to use something like this, they just get a reference to this and then execute a task on it. And the framework should take care of picking the right node, ensuring there is mutual exclusion, ensuring there is fault tolerance, and so on and so forth. Another area where this might be applicable is you can look at how we execute intents that are submitted to the system. We distribute that across the cluster for load balancing reasons. And we sort of do that manually. We have a one-off process there. It would be nice to create an abstraction or a primitive that makes it much more easily accessible for others with a similar use case. So that is again something that would fall under this bucket, not necessarily tackled in EMU, but again, this is something that would be classified as a primitive for distributed execution. Another area where we would like to spend some time is provide some primitives for message passing with stronger guarantees. A common use case we have today is one instance wants to send a message to the master for a device. And the way it does that today is check the mastership service for the current node, which is the master, and then send a message using the cluster communication service. Now, the sender has to deal with failures. And usually, by the time, that happens, there could be a mastership switch. So things can get really messy when you factor in all the different failure scenarios here. If you sort of, invert this, one way to do it is, you send a message to the device, and the current master for that is responsible for, processing that message. And this will work even if there is a mastership switch right when you do this. So again, something that would make this much more easier for application developers or for other service developers to work with. Finally, we want to start incubating this notion of a region. A motivating use case here is, say, for example, you have your network elements spread out geographically. A common preference is for controllers which are closer to a network element to manage that device. And if you look at how things get assigned today, it's sort of done in a random fashion. A switch that comes up first, it basically ends up being mastered by the controller that it first connects to. And also, there is a leader election that goes on. The outcome of that is random. And when you factor in this sort of external requirement that we prefer controllers closer to a device to manage it, we need an abstraction that will make it easier for us to express these kind of preferences. And region is, you can think of it as an abstract concept that will let us group network elements into these classes, and then you can administratively manage them as a single unit. And it will also sort of define who will take over if a given controller fails, and so on and so forth. So it basically sets up this preference order for managing or administering a set of network devices. So roughly those are the high level areas that we will be focusing on MU. If anyone has any questions, I can.
The message queue, can you give an example for the message?
Sorry?
Give an example for the message.
So an example, as in like a specific. So today, if you're trying to install a flow rule, right, that can be only installed from the master for a device, right? But any instance in the cluster can initiate that, right? And today, what we do is we basically send a message one way, or using the low-level cluster communication primitive, which doesn't provide any fault tolerance. So you can, that's an example.
Thanks. All right, Ali.
Hi. So for the southbound, we should bring in support for open config, and support for incoming netconf, and therefore Yang. I have Yang on my side. Hopefully, I won't get thrashed. Models for the OLT and G.fast and other devices. There's probably going to be some OBSDB improvements, because there's some need for that. And we're going to, that work has already started, but it had to be paused for a second. Upstreaming Loxy back to Loxy people. And so we're still waiting for a couple pull requests to pass, and in the meantime, we received new contributions to our Loxy, so we're going to push those upstream as well, and hopefully we'll get to a state where we can push that library out into push that library out of our own repo, and we don't have to maintain it ourselves, which is annoying. And also, there's going to be BGPLS support as a provider. That's all I had. Any questions?
What's this, the last one mean?
The next page?
Yeah, it's kind of,
BGP link state. It's a variant of the BGP protocol that allows you to collect topology information in the router network.
Okay, so since Bob asked, let's go there.
Satish.
Hello. Hi. Yeah. Hi. This is Satish here from Huawei. Yeah. This is regarding the BGP LS, like what we discussed in the previous slide. So we provide. Can you go to the next slide? Yeah. So here the idea is we'll be having the BGP link state distribution protocol, BGP-LS, as an SBI port, okay? And through this BGP link state protocol, we'll be learning the topology information of the IGP network in the below network, okay? So maybe OSPF or ISIS, any of the IGP protocols can be learning. So these protocols will will provide the link state information as well as the T information, traffic engineering informations to the BGP-LS in the network. So this will be pushed to the controller southbound, so where we will act as a southbound protocol. So from here we learn this link state information, and we will send this node, I mean the device information as well as the link information along with the TE parameters to the core. Okay, so the use case here will be like in future maybe some applications like PCE, so which will use this topology information. Okay, so basically for traffic engineering, so they'll use this topology information to build the path between the ingress and egress. So with the constraints like bandwidth or cost or the color or SROG or any of the TE parameters. Okay, so once the path is computed by this PCE, so they can use this. They can set up a path using the PSEP, which we already have in our previous release as an SBA. So the using PSEP tunnel can be created between the ingress and egress. Okay, so this is the idea behind this BGPLS link state protocol as an SBA. Okay, so can you move to the next slide? Okay, the scope of this protocol development is design and implement the BGPLS SBA. Okay, and here we'll be implementing the basic protocol like BGPLS, whatever the RFC says, and also we'll be having the BGPLS topology provider, which will interact with the core using the link, using the device and the link provider as an SBA. Okay, as well as the peer establishments, more than one sessions can be established. So this all related to protocol will be taken care here and the provider as well. And using the BGPLS SBA, will be injecting the network informations like device informations, link informations, and the prefix which is being attached to the device. All the informations will be injected to the core, so the core can maintain it. Okay, so the next slide, please. Oops. Yeah, these are the epics, tasks, and Jiras has been created for this project already. This is already there being created in the Jira of ONOS. Okay, so maybe we can skip this. Maybe details we can check later, like what are this task about. So basically, it's about the design and implementation as well as about testing. So regarding the demo plan, we are planning by October 2nd week or 3rd week. After finishing the testing and other stuffs. So we are planning to use the current GUI we have for the topology manager. So but currently which shows this was for the, what are the GUI we have which will show for the open flow switch. Currently it's like for the switch, open flow network, open flow switches. So maybe we can use that, maybe in order to show the T parameters, we might require to extend this GUI as well to show the traffic engineering parameters as well as the layer 3 parameters, like whatever the parameters which we get about the node as well as about the link. So for this we might need to extend the existing topology manager as well in the core, so to handle these informations, these extended informations of the L3 network. Okay, so the next slide. Okay, the test plan is we are trying to use the Huawei devices as a network in the network, and our controller, ONOS controller, to manage this network and learn this topology. Okay, so we are planning to use the same thing for as well as for the demo purpose as well. And the wiki page has been created and the link has been provided, like BGP link state protocol, distribution protocol. The link and this web page has been added. The basic information has been added now. So we'll be adding more details soon, like the more depth information about this SBA part. The next slide, please. Okay, I'm not sure whether we can discuss these issues here. If you guys are okay, maybe we can discuss this. Actually, what are the? This I highlighted some of the issues which I face when I want to extend the current interface with the SBI, the device and the link provider service interfaces.
Yeah,
so is it okay? We can discuss this.
Yeah, I would suggest we leave it at that. Just saying we need to have a discussion, but I don't think this is a forum to be looking at the code, discussing, design pitfalls.
Okay.
My suggestion.
Thomas?
Yes.
Can we schedule a time slot the next time when you are doing the TST meetings and talk about this one? Okay.
I couldn't get you. Can you come again?
We'll schedule a. We should schedule a TST item on the agenda.
Sure. Yeah, that would be better. Okay, that's it from my side. You guys have any questions? Maybe we can discuss on that.
No questions. Okay, thank you.
Yeah, thanks.
It's your time is very late.
That's okay.
Thank you very much for the guys.
Yeah, thanks. Bye-bye.
Goodbye.
Okay, so that's kind of like. You ready? Okay, so that's it for the planned agenda topics. So what's happening next, if the mic still works, is that we're going to enter epics and stories over the next week. We'll begin our 3-week sprint cycles. First one beginning on the 21st. Just a few comments about Chord. I think there's some confusion here, and I just want to try and clear it up. So Chord is a pretty large and complex project, and so we decided it wouldn't be a good idea to just keep everything with Chord inside of the ONOS project. So we did keep it on the shared calendar with ONOS, but we've separated the Scrum boards. So there's a few different Scrum boards now for Chord. We will try and keep it on the same release and sprint cycle as ONOS. That way we do the planning on the same days and we do the demos on the same days. So hopefully that will keep us from having a proliferation of planning and demo meetings. Okay, so we'll give that a try and see how that goes. Okay, so that's all I have. Anything else?
I'm not sure if there is any dependencies in the current emu release with the Chord. If you are running the code development separately, what's the plans to deal with the dependencies if there is the dependencies? I'm not sure if there is any dependencies, but from the Chord perspective, now it seems like the branch management is the code management is not so big.
Okay, so there's a third topic for TST.
Okay. I think that we probably need to define identify the dependency first. Then we'll come on approach. Because for time being, to me, I don't know if there is any dependencies.
Okay.
Yeah.
Fair enough.
We may also consider on that one subject changing it to every week, even though in the past we sort of struggled having it regularly. We'll probably have it every week, and so this way, if you miss it due to travel, like next week, for example, or through other engagements, it's not going to be that much of a problem, not that much of a problem. So we'll discuss more and probably some announcement. But I would suggest in the meantime, if there is topics for TST conversations, go ahead and add them, either email them to me, or you can just update the wiki page with the agenda. There's pending agenda items and just put them.
Yeah.
Or send a message to the Slack channel.
Okay. All right, that's it. Thanks everyone for joining.
Yeah, good.